Welcome to another edition of Math for Mobius. In this edition, we are looking at this problem. We are given this transformation hz, which is az plus b divided by cz plus d, and a, b, c, and d are all complex numbers. We satisfy the condition that ad minus bc is not equal to 0, and z takes all complex values except the value minus d by c. C is of course assumed to be non-zero. Now we want to investigate whether this function h is 1, 1, and also we want to find out what is the range of h. So these are the two questions that we want to investigate in this problem. To check h is 1, 1, let us suppose hz1 is equal to hz2 for some z1, z2 which belongs to the domain of h, which is c minus the point minus d by c. If h is 1, 1, then you would be able to conclude that z1 is equal to z2. So hz1 is az1 plus b divided by cz1 plus d, and hz2 is az2 plus b divided by cz2 plus d. Cross multiplying we get this, simplifying we get this expression, and we note that acz1 z2 cancels on both sides, bd cancels, so we get ad minus bc z1 is equal to ad minus bc z2. Now we note that ad minus bc is assumed to be not equal to 0, so we can cancel both sides and get z1 is equal to z. So whenever hz1 is equal to hz2, we get z1 is equal to z2, and therefore we can say that h is 1, 1. So this mapping h is 1, 1. Now we have to find the range of h. We would try to figure out what are the possible values of u that is taken by the mapping, which would mean that for such values of u, there will be a z for which az plus b divided by cz plus d will be equal to u. Simple algebra gives us that uc minus a times z must be equal to b minus u. Now, if uc minus a is not 0, then we can divide by uc minus a to get a value of z. So, for every value of u for which uc minus a is not equal to 0, we have a value of z for which h of z is equal to u. So, h of b minus ud divided by uc minus a is equal to 2 whenever uc minus a is not equal. So the point for u for which uc minus a is equal to 0 is not in the range of h. So for the value of u is equal to a by c, there is no value of z for which h of z is equal to u. If we put h of z is equal to a by c, then simple algebra gives us ad is equal to bc, which is a contradiction since we have assumed that ad minus bc is not equal. So there is no value of z such that h of z is equal to a by c. Therefore, the range of h is c minus this point a by. It's a good point to stop. Thank you.